We will go ahead and get started. Welcome again to this meeting. It's a public meeting on well V201 located in the SCV Water Service area of where's that? Valencia Boulevard in Santa Clarita. My name is Kevin Strauss. I'm the communications manager at SCV Water. Before we get into introductions, I do want to do some housekeeping for this afternoon's presentation and meeting. First of all, this meeting is being recorded as part of our public interaction and public engagement process. A recording will be emailed out to all attendees, all registrants. It will also be posted on the yourscvwater.com website and sent out on SCV Water social media channels within the week once this meeting is completed. For the Q&A portion or any questions or comments that you have, you can feel free to use either the chat or the Q&A box at the bottom of your screen. Type in those questions. We'll come back at the end of the presentation and have a moderated Q&A back and forth about any of the presentation material you've seen today, or the draft report, or other questions you have about this process for V201. Reminder, if you do have public comment or you want to submit any questions or concerns about this process, about this well, please email them to myself, Kevin Strauss. Information is on the yourscvwater.com website about how to send in your comment. I'm also going to type my contact information into the chat so you have that for later. And again, this recording will be posted as soon as we can get it turned around, likely tomorrow. With that, I'd like to turn over for some introductions for our speakers today. They'll tell you a little bit about themselves, their affiliation, and their role in this process, and then we'll get into the presentation material. So first, we'll start with Jenny Anderson from SCV Water.
Yeah, hi. Thank you so much for having me. My name's Jenny Anderson, and I'm a water quality specialist at SCV Water, and I've been working on restoring well 201 for the last handful of years in conjunction with the Division of Drinking Water.
Saeed?
Good afternoon, everyone. This is Saeed Hafiz Nizami, and I'm with the State of California Division of Drinking Water, and my position is 9705 Project Manager. Thank you.
And would anybody else on the presentation, on the panelists, like to introduce themselves? Bill, Mike, Ryan?
You're on mute, Bill.
Sorry about that. Hi, my name is Bill Liang. I work for the Division of Drinking Water as one of the 4 district engineers. My team and I regulate Santa Clarita Valley Water Agency, and so this is kind of one of our projects. I will not be presenting. I'm just kind of here to provide support to Saeed, who will be presenting on behalf of DDW. Thank you.
Hello, I'm Mike Alvord. I'm Director of Operations and Maintenance at SCV Water. And similar to Bill, I'm not here to present, just as support for Jenny. And looking forward to getting V201 online, and wanted to express my thank you to Bill and Saeed and the team at Glendale Division of Drinking Water in their support in helping us restore this well and get it treated. Thank you.
Ryan is trying to get on, but either way, Ryan is here as well. Go ahead, Ryan.
Yeah, my camera's not working, but my name's Ryan Bai. I'm a water system supervisor here at SCV Water, and I'm not presenting, but I'm here to support Jenny in her great work that she's done with DDW and restoring 201 back to service.
Thanks, Ryan. Thanks, everyone. So right now we're going to turn it over to Saeed to start the presentation materials. And a reminder, please type in your questions into either the Q&A or the chat box at the bottom of your Zoom window. And again, I put my information in the chat for any follow-up public comment or questions afterward. I'll be back at the end of the presentation for Q&A. All right, now, Saeed.
Thank you. Okay, can you guys all see my screen?
Yes.
All right, perfect. Thank you so much. And before I begin, I also want to apologize. My voice might be a little rough to hear. I've been dealing with a cold, but I try my best not to cough too much during this presentation. So with that, good afternoon, everyone, and thanks for attending this public hearing. Again, my name is Saeed Hafiz Nizami, and I'm a Senior Water Resource Control Engineer representing California's State Water Board Division of Drinking Water. And my job is to oversee and help Bill and his staff regulate extremely impaired source water projects that we refer to as 9705 projects. And I will describe what that definition, what that 9705 means. So I want to start by introducing my agency that I represent today. It's called the Division of Drinking Water, or for short, DDW. So we at DDW are tasked with regulating public water systems such as Santa Clarita for ensuring protection of public health. So our main objective is public health protection. And accordingly, we undertake many different roles and tasks to accomplish that goal. And here are some of the things we do. We do enforcement, development, and implementation of various state and federal regulations related to drinking water. We issue permits to water systems, again, such as Santa Clarita, for operation of their facilities and distribution of potable water, as well as ensuring compliance with these standards and inspection of the various components of the water systems. So the reason I'm here today is because Santa Clarita SCV has applied for a drinking water permit amendment, which we have been evaluating and preparing the permit for some time now. So here's a little bit of our philosophy on impaired sources of water. So DDW's goal is to assure that all Californians have access to a reliable supply of safe drinking water. And accordingly, it is our stance that the best quality sources of water that are reasonably available to a water system, to a water utility, should be used for providing drinking water. Extremely impaired sources are those sources that contain or are likely to contain very high concentrations of contaminants, multiple contaminants, or unknown contaminants. An example of these sources are groundwater sources that are subject to contamination from a contaminated site. So we also recognize that in certain cases, the water produced from treatment of these impaired sources can be a potential resource for water systems, especially when other available supplies are limited. And that's where this process memo 9705 comes into play to address the inherent risk of using these sources by establishing steps to review and evaluate the proposals for using these extremely impaired sources in a safe manner. So what is this process memo 9705 that I keep referring to? This is a guidance that was issued to the drinking water program at the time back in 1997, which is now called the Division of Drinking Water. This guidance was issued to our staff on how to permit the use of extremely impaired sources of water for domestic use. So that's the terminology. 97 is referring to the year that this was originally issued as a memo, and it was the 5th memo issued in that year. So hence we've kept the name 9705. So basically what this process memo establishes, it establishes a process for permitting these sources for potable use. And a revised process memo 9705 was issued in 2020, which superseded and updated the initial memo based on all the experience that was gained over the 2 decades and all the permits that were issued to these similar projects in that time period. And this is a public document that can be accessed online, so anyone can go to this link provided on this slide and review this process memo. So this is the screenshot you see here is the revised process memo from 2020. So this is just an overview, a summary of what this 9705 process entails for permitting extremely impaired source projects. I'm just going to briefly go over the overview, and I'm going to spend a little bit of time on each step. But basically, a water system or a project proponent that wants to use an extremely impaired source of water, it must undertake various steps to gather information and prepare technical reports that summarizes the outcome of each of those steps. And these technical reports will be submitted to DDW to help us review and evaluate the permit application. And this is the key supporting documents for us to use in our permit evaluation. So this process is a hefty, lengthy process. It involves receiving and evaluating extensive amount of information, data, analysis, and conclusions, prepared by the project proponent and reviewed by our DDW staff. And depending on each project specifics and specific circumstances and details, we determine whether all or some of these steps are required. These various steps are listed here in the order that they need to be completed. And it starts with drinking water source and contaminant assessment, followed by characterization of raw water quality, source water protection, effective treatment and monitoring, and a risk assessment for the failure of proposed treatment if warranted. And I just want to point out that these steps in this evaluation process are sequential, meaning each step relies upon the findings and conclusions of the prior step. So these are the major 5 steps in the 9705 review process. And besides the completion of these steps and the review and approval by DDW, there are also other documents and steps that need to be completed prior to issuance of a water supply permit issued by us by DDW. And these steps are, they include preparation of CEQA documents, permit application, preparation of a operation monitoring plan, and also holding a public hearing if deemed necessary by DDW. So that's the reason we are here meeting today, is because we require a public hearing as well. So the very step of this process, I'm just going to spend a little bit of time going over each process. This is the first step, is an assessment of the impairment or the contamination. So the objective of this step is to, because we need to know what contaminants are present or are likely to be present at the source, impacting the water source and also into the future. And this is the subsequent, this is the foundation of all subsequent steps. Here are some illustrative examples of outcomes of this assessment. These are some examples not related to this project, but these are some of the outcomes of this process that we expect to see. Maps showing the extent of the contamination plume and tables listing the various contaminants of concern for the specific project. And like I said, a lot of time and effort goes into preparing all this information as well as reviewing it. Step 2 is characterization of raw water quality. And the end product of this step is estimating the contaminant concentrations that will be fed into the treatment system. So the project will need to determine all the contaminants that are currently present or will be present in the future at the production wells, and estimate the maximum concentration of those contaminants. And that is the basis for the treatment design. We want to make sure that the treatment system is adequate in treating all the contaminants at the maximum concentration foreseeable. So again, this process looks at the trends of water quality and concentrations of these chemicals and their variability, and it involves a lot of modeling, mathematical methods, modeling techniques, and different assumptions that need to be described and justified here. I know if there's any comments, I'll look at the chat box at the end. Next step is step 3 is the drinking water source protection. The purpose of this step is to make sure that the water system is on top of all the activities and developments in the watershed or in the groundwater basin over time, and to prevent any new contaminants from getting into the production wells. So we want to minimize the dependence on the treatment. So we require water systems to have a program in place to do source control, to look at ways to control number of contaminants or the concentrations from rising into the future. So it's very important for the water system to have specific liaison, a team to communicate and coordinate with other agencies and other regulating agencies involved with any cleanup programs. And next step 4 is the effective treatment and monitoring. The purpose of this step is to ultimately treat the contaminants of concern for the project to the lowest level possible. And this is where we spend a lot of time and effort, again, reviewing all the details of the proposed treatment technology to ensure that they are performing reliably and adequately to produce safe drinking water. And, given that these projects typically contain a group of contaminants, we must employ a specific cumulative review methodology called maximum contaminant level MCL equivalent approach, which is basically ensuring all contaminants of concern are treated to the safest level possible. And then the next one, step 5, this is treatment failure health risk assessment. And the purpose here is, if warranted, to understand and quantify the level of health risk that these projects pose if any treatment process could ever fail. So here our goal is to identify any risks and minimize them by requiring additional safeguards that we incorporate into the permit requirements. So these could be different types of monitoring, alarms, compliance monitoring, performance monitoring, which are all incorporated in our permit that we issue to the system, and the system needs to have that monitoring program going and starting the operation of the system. So that was just a very brief summary overview of the 9705 steps. And I should also mention the other items that need to be completed by the projects, such as completion of CEQA requirements for these projects, which is similar to all other permitted projects. These projects, they also need to comply with CEQA, California Environmental Quality Act requirements. And these 9705 projects, again, they're similar to other water supply permits. So the proponents are suppliers of this treated water. They have to be permitted as a public water system. This is requirements by the Safe Drinking Water Act. So as part of that process, the water system needs to submit a permit application to DDW for the use of this source, which, again, our job is to evaluate and impose all the stringent requirements on them as necessary for protection of public health as part of the conditions of the permit. And a public hearing may be needed to ensure that public is aware of these projects and there's public acceptance of the treated water. And we always recommend engagement with the public by various forms of outreach. And one of those method is holding this public hearing. And then finally, DDW findings for approval of externally impaired sources include these criteria that are listed here. So we want to make sure that all the water standards, MCLs, action levels, notification levels for the drinking water are not exceeded. We want to make sure that the human health risk is minimized by the treatment. We want to make sure that the treatment system has safeguards, redundancies, maintenance and inspection, monitoring and alarms. And then at the end of the process, DDW, once evaluating all these different components, either issues or denies a permit for the use of the source. And lastly, this is my last slide. I just want to conclude by saying that once the project is permitted, once the permit is issued by DDW, our role is not over. As I mentioned before, we have conditions specified in the permit for the lifetime of the treatment plan, including routine sampling and monitoring, of the source water, of the treatment processes, and the final finished product water. We also have special monitoring requirements for the upgrading and surveillance monitoring wells to make sure we get early warnings about any potential changes to the water quality down the line in the future. So we have various requirements for the system to reevaluate different components of the system. And if at any point in the future any of these conditions change, and if those changes warrant, we may have to reopen the permit and make another amendment in response to those changes. So that concludes my presentation. I appreciate your attention, and with that, I hand it over back to Santa Clarita staff.
Thanks, Saeed. I appreciate that. Before I turn it to Jenny to present, I made a mistake before. I typed my contact information in the chat, but I only sent it to panelists. I'm going to put that in the chat for everybody to see now. If you have any follow-up questions after this meeting, or you want to submit a public comment as part of this process, I'll put my email address in the chat in a moment. We're going to turn now to Jenny Anderson from SCV Water to present Santa Clarita Valley Water's process through this and steps that have been taken through this process. And then we'll get to questions. I did see one come in from Ms. Planbeck that I do want to address. I'll do that at the end because some of that might be answered through this next portion of the presentation. If not, then I'm happy to jump in at that point. But thank you again, Saeed. If you can stop sharing screen, and then Jenny can pull hers up.
Thank you. Saeed, can you unshare your screen?
Oh, sorry. Am I still sharing?
Yeah.
Oh, I see. There you go. Thank you.
Perfect. Can everyone see it? The screen? Kevin?
Yes.
Perfect. All right. Well, thank you everyone for joining us today. We're very excited to share this Well 201 project with you. This project is about restoring a vital groundwater well back into service with the removal of perchlorate and VOC treatment. So SCV Water has a very vast service area. We span all the way up the 14 freeway towards Canyon Country or through Canyon Country, and all the way west of the 5 freeway into Castaic. We actually approximately encompass 196 square miles within the Santa Clarita Valley. And then Well 201 specifically is in the heart of the Santa Clarita Valley, as you can see in the little red dot right there. It is located on Valencia Boulevard, across the street from the Valencia Town Center and just south of City Hall. So perchlorate and VOCs have been found on the Whitaker Bermite property, which is located in the center of the Santa Clarita Valley and is just south of the Soledad Canyon Road, and it is directly above our aquifer called the Saugus Formation. So this Saugus Formation underlies the Santa Clara River and is approximately 2,000 feet below ground surface. And then just to kind of go over, perchlorate is a component of like fireworks, explosives, solid rocket fuel, and then VOCs is a source of pollution generally by the environment, sometimes found in groundwater and underneath certain industrial businesses. Our agency has been committed to removing perchlorate since 2010. Our Saugus Perchlorate Treatment Facility, or SPTF, as you see in the picture there, was our first perchlorate treatment facility in this entire valley. And this facility alone restored 2 wells back into service with a combined production rate of 2,200 gallons per minute, and it does operate year-round. So 201, it was constructed back in 1989, and it is drilled to a depth of 1,690 feet below ground surface. So it is completely in that Saugus Formation aquifer that I was just discussing. We decided to take a proactive approach when we were designing the Well 201 system. We are going to be using ion exchange for the removal of perchlorate and granular activated carbon, or GAC, for the removal of volatile organic compounds, or VOCs. And this is going to be restoring nearly 2,000 gallons per minute to our water supply. And that's actually enough to serve about 6,400 Santa Clarita families each and every year. So just as I mentioned, it's going to help increase our water supply restoration, and it's going to increase our local water supply reliability. It's also going to act as a containment well, and it will help pump year round to limit that potential plume for perchlorate to spread further west into other drinking water wells. And then, as mentioned, we're going to be using ion exchange as well as GAC, which have all been known, effective, and proven treatment technologies. So in terms of the water quality for perchlorate, the concentrations have ranged from below the DLR, and that's detection limit for purposes of reporting, up to 18 micrograms per liter. The treated water goal with this system will be below the detection limit for reporting, or the DLR, of 1 microgram per liter in the ion exchange lag effluent vessel. And then for VOCs, we're actually really looking at TCE, or trichloroethylene concentrations, because they've had detections that have ranged from below the DLR up to 1 microgram per liter. And our treated water goal will be below the DLR of 0.5 micrograms per liter in the GAC treatment effluent vessels. So in terms of safeguards, the ion exchange is going to be operating in a lead lag configuration. And what that means is that when the lead vessel becomes exhausted with perchlorate, that lag vessel will continue to remove the perchlorate to a non-detect level. And then once we have a resin replacement, that former lead vessel will now become the lag, and that lag vessel that has already been partially used or has some perchlorate will now be moved up to the lead vessel. And then for the GAC vessels, we're going to have 2 vessels that are going to operate in parallel, and those vessels are going to achieve a 10-minute empty bed contact time to provide complete VOC removal. And then additional safeguards, we're going to be using the Supervisory Control and Data Acquisition, or short for SCADA. And this is going to give us early warning signs of potential issues. It's going to give us real-time oversight of system performance, and it's going to really automate when something falls out of like what we would call the normal operating conditions. And then for routine sampling, the treatment facility will be sampled weekly for perchlorate and VOCs, and then additional sampling will occur monthly, quarterly, and annually for other constituents. We do have a triggered monitoring in place for VOCs at the GAC vessel. So monitoring will increase to weekly after we have 2 consecutive monthly TCE or any type of VOC detections at the 50% port. And then our monitoring wells, like Saeed kind of mentioned, we're going to rely on our monitoring wells, which also act as an early warning system. And so they're going to help us detect any potential contaminants moving towards 201 before they reach the well itself. And that allows us to actively respond and to be able to protect the water quality at 201. So for the project history, we've been working and collaborating with DDW for nearly 10 years to restore well 201 back into service. Last year in 2024, GAC was added to the permit to remove low-level VOC detections. And then this past September, DDW came and actually completed a site inspection at the 201 treatment facility. And then we are excited to have our first GAC treatment for VOC removal placed into service before the end of this year. So construction, these are actually pictures from the 201 treatment facility site. So you can see on the left, you have ion exchange vessels, and they operate in a lead lag configuration, and the GAC media vessels that operate in that parallel configuration. So I know I've been talking a lot about resin and GAC, but really what is it? These pictures are actually really good to just kind of show you what they really are. But by definition, ion exchange resin, they're really just tiny like porous beads, and they're used to remove unwanted ions from the water by swapping them out with other ions. Whoops, sorry. And think of them as like magnets, where that they'll be attracting and holding on to specific ions and releasing others in a process called ion exchange. And then for GAC, we're going to be using a coconut granular activated carbon, and it's actually a filtration media made from coconut shells, and they're heated up at a very high temperature and essentially activated to create millions of tiny pores. And this allows the tiny pores to have a larger surface area so that they could effectively adsorb or grab onto contaminants as water flows through it. So our return to service, as we are doing right now, we are currently under the public review comment period, which ends later this week on December 6th. We will be completing water quality samples by the end of this week. And once we receive the results, we'll be reviewing them and then submitting those results to the Division of Drinking Water for approval. And then DDW will issue the final permit and the well will be placed into water or online, excuse me. Are there any questions?
Sorry, I clicked my audio button, but it didn't come on. Thank you, Jenny, for your presentation, Saeed, as well. I do want to address some questions that we have in the chat and allow others to process the information as we get going. First question from Ms. Planbeck that I'm seeing second, but it's good to respond first. Will these presentations be available on the SCV Water website? This video will be posted on the website, I believe, by tomorrow, if not the next day. It'll also be sent out to all attendees as a recording, so you'll be able to click through and watch the presentation again and scrub through at your own speed. The second question that came in, and I'm going to put information into the chat about from Ms. Planbeck, is this a public hearing? In the past, specifically with Saugus 1 and 2 processes for this, there were documents for the public to review first. Yes, Ms. Planbeck, the public was notified of available documents on November the 7th, and a press release that was sent out and reported on in the media. It's been on our website since that date. That's where the registration link for this meeting is. I can put the link to that in the chat and show where those documents, the draft report and appendices that you can read through. And again, the public comment period ends at 5 p.m. on Saturday, December 6th per this process. So there's a little bit of time left, not a whole bunch, but the documents have been online since the 7th of November. Other questions coming through? Please feel free to put them in the chat or into the Q&A. And another question from Ms. Phillip following up. No, the carryover period, no, it's a 30-day comment period. So we started on the 7th and that feeds into December the 6th.
Kevin, if I may, I also want to just point out something. I just realized I think the cover page of my presentation, it had the wrong project title. So I will just send you the correct version if you want to post it.
That'd be great. Thank you. Posting in a link directly to the engineering report, as well as the landing page for the documents, and the appendices are listed in a menu just below that on the groundwater restoration landing page. There are 26, so I'll not be linking those individually, but they are on the website individually linked out, and that's more of the data and figures. All right, I'll give another moment or two for any last questions or from the panelists, last comments to close out, or things that you wanted to address before we did.
I would just like to thank you, Kevin. For some reason, keep clicking my camera. I'd like to thank you, Kevin, for putting this on and hosting this. I really appreciate it, and thank Bill and Saeed for their help and efforts in helping us get this to the finish line. So, and of course, Jenny and Ryan for lifting the heavy stuff to get the permit approved. So, thank you all.
Thanks, Mike. And with that, again, I appreciate your time and attention joining this meeting tonight for Well 201. If any questions come up afterward, or you want to submit a public comment after reviewing the documents, please send me an email. My email is in the chat. It's kstrauss@scvwa.org. And we will take this presentation, put it on the website, and post it out through our social media channels as soon as we can get it posted. I believe you also get a direct email that says a recording is available to view. If not, it will be on that page that I linked in the Q&A portion now. So again, with that, thank you so much, and I hope everybody has a good night.